Yeah. So welcome to DGD 8th session. This session will be covering wave motion, and that is chapter 16th of your book. Let's go ahead and solve question number 1. Let's read it first. So the question says tension is maintained in a string as in figure. There is a tension in the string. It will always be there whenever something is hanging or something is pulling something. Tension is always there. The observed wave speed is given when the suspended mass is 3 kg. Okay. What is the mass per unit length? You have to find a a to find mu mass per unit length, or V is given as, you remember this formula?
Yeah.
Okay. So this is mass per unit length. This is speed, wave speed.
I actually already did this problem, but I think
Okay.
it'd be good
But
for the
I have to
others.
do it anyway.
Yeah.
Do it anyway. So I'll go it quick. So you can find this by, and I won't take much of your time because I think you have to prepare as well. So I'll go it fast today. If you think somewhere it's shady, you can stop me there. Okay?
Sounds good.
Sounds good. So, and where you can find F, what happens? Where you can find F as mg, right? And same in B, mass is 2 kg. Then you have to find mass, force, F, Fn, and then you can apply. Now you have to find this wave speed. Okay? N means new. Okay, I hope you got it and you solved it already. Let's change it to the. This is more a conceptual question. If it won't be in your exam, but if yeah, I'll go through it quickly. So in a region far from epicenter, a seismic wave can be modeled as the transporting energy in a single direction without absorption, just as a string wave. So you can think as seismic earthquake as just a wave traveling in a string. Okay, if it's far from the epicenter, I mean where the wave originates from. So suppose the seismic wave moves from granite into mudfill with similar density but with much smaller bulk modulus. Assume the speed of the wave gradually drops down by a factor of 2.50 with negligible reflection of the wave. So now moving from granite, that's usually it's in the building blocks of the building, right? In the base of the buildings to the open grounds, okay, to the muddy. So we have to explain whether the amplitude of the ground shaking will increase or decrease. What do you think?
Um,
Just think about it physically. This is a good way to solve the problem. So you are shaking something, right?
right.
And something is more rigid and something is less rigid. Which will shake more?
The less rigid
Yes. So the amplitude should increase or decrease?
increase.
Yes. So we can find it, right?
Right.
So you can think of it as well. This, what is power? Total power carried is where A is the amplitude, V is the velocity of the wave, right? This is another way of looking at it. and you know everything else, right? So,
Hmm.
so as said in the question, if it's far from epicenter, as given, it's far from epicenter, it can be considered as a wave traveling on string. That means rate of change of energy with respect to time is constant, right?
Right.
That means every wavefront is carrying same energy, right?
Hmm.
Same energy. That means if your speed is decreasing as given by a factor of 25, then amplitude should increase. Get it?
Yeah.
That's the mathematical way of looking at it. Mm, okay. And the math is pretty easy. I'm donating all the factors 1/2 mu omega square by a, not sorry, b, any constant, okay, a square v, and I can write, because the total energy should be conserved, a square v of granite, granite, and this is, what was the other thing? Mud, right? Mud, mud. So you can find a mud by a granite. The values you can find by this. So v granite by v mud. So you can substitute the values and the answer will be 5. I did that. So okay, because this is divided by 25.
Right.
It's written here. So it'll be, I'll do it. Doesn't matter, just one single line. It's v granite by into 5. Okay, into 25, and that would be 5. Okay, so does it change by a predictable factor? Yes, I think 5 times is a predictable factor, right?
Hmm.
That's why this led to the collapse part of freeway, blah blah blah. But I think if people apply physics in real life and think logically, they will find a lot of logic behind a lot of stuff. So
Right.
that was my motive of picking up this question. Okay, and I just was giving wanted to give you guys advice, and it's just you. I think your prof will pick up questions on wave equation.
Hmm.
Okay, it's the thing that's used in every part of physics, even in higher quantum mechanics, advanced quantum mechanics. So quantum optics, everywhere they use wave equation all the time. It's the most famous thing. So uh, practice questions on wave equation. Okay, I I did choose these two, but we'll come to it. Moving on to third question. A long string carries a wave equation. Sorry, carries a wave. Sorry for that. Carries a wave. 6-meter segment. The length of the wave is given and contains 4 wavelengths and has a mass of 180. Okay, so mass is given. Did you try this problem?
Yeah. I did
Okay.
all the problems in the book that have the answers.
Oh, so this has the answers.
Yeah. When you click on the box, it shows the answer.
Oh, so I should never pick those questions? Is that like that?
No, well, I don't know. I think some people haven't done it, so I think it'd be helpful for them to know how, because we don't get the solution, we only get the answer.
Okay, and if you, yeah, so you can always check whether you're correct or not.
Yeah.
Okay.
But only some questions have the answers, not all of them.
I didn't know that. I usually pick the challenging ones, but I think people mailed me and said they are difficult and don't like just put one or two of them in the DGD and I don't know.
Yeah, I think some of the harder questions like do a little bit less because our midterms are fairly straightforward in terms of the questions. They're not like super
Okay,
complex
okay,
questions.
okay,
But I think the questions that we did today were pretty good. Also
okay.
very similar to like our homework.
And the one we are doing right now?
Yeah, like I feel like it's like our homework level
Okay,
question. Yeah.
okay, okay. That's cool. So first question is asking first that write the function that describes this wave. It's given it's a sinusoidal wave, so it's definitely a sine wave. So your wave can be written as a sine kx minus omega t, right?
Right.
That means a wave traveling in the x direction. You don't need that, right? So k is 2 pi by lambda, right? Omega is given 2 pi f, right? And also k is, lambda is given contains 4, so 6 by 4, right? Lambda is given as 6 by 4,
Yeah.
and you have k, you can be find by 2 pi by lambda. You can find k there, and then you can find frequency by 2 pi f. What else do you need? You have everything. And a is 15 divided by 2, 7.5. That's okay?
Hmm.
Centimeters or 0.075. Determine the power. Power formula, as I wrote before, is that's A part, that's B part, mu omega square. Actually, I wanted to ask, make it a revision session, but the thing I did like I did before, but
Hmm.
nobody sent. And even I asked Prof, like, what's the syllabus? I think he was busy or something. Nobody else gave me the syllabus as well, so I didn't know. This will be the answer, okay? And I think you did it. For only thing needed is V. V is given by omega by k, right?
Right.
Otherwise, every other value you have. So, do you think what's the physical significance of this formula? Uh, can I ask you one question? Like, which field are you from?
I'm in biomed.
Biomed?
Yeah.
Okay, then you don't need to go into that. Yeah. Let's go. Yeah, yeah. I won't bore you there. Okay. So, so that's the favorite equation of every person in the field of physics. Okay. There should be C or C square.
Sorry?
In the bottom, it should be C or C square.
I don't know.
Okay, so here's the thing. That's what I wanted to give you the trick. Okay, if you ever come across this equation, there's something called dimension equality. This
Okay.
has the dimensions of length square, right?
Right.
And what is length? Speed into time. Yes.
Yeah.
Then this is on the denominator. This is c into t square. So this should be c square, right?
Right.
So this should be c square. That's how you remember things.
Oh, okay.
Okay. Dimension equality. So remember that. Okay. This might help you. This will might be so. Which one would you like me to solve, both, or you like me to solve, I think, both?
Both, yeah. I haven't done these.
And I'll tell you why, because these are mathematical and your prof might ask him. So what is dy by dx of this? Is it, you agree with this? So d of dx of ln bx is, what the heck? Yeah, is 1 upon bx into b. Do you agree with this?
Yeah.
Okay, so this will cancel out. This will be 1 by x minus bt. So now d2y by dx squared. That's okay. Nope. Yeah. I'm unable to listen to you. So, to go back to the chat box. Are you there? Yeah. So d2y by dx squared, and now let's find dy by dt. Mm, dy by dt, or y dot is, okay, d2y by dt squared, y double dot. Do you guys agree with me here?
Yeah.
So this will be, if you don't understand any step in derivation or differentiation, you can ask me. Okay, so now you just put in the wave equation. So LH, left hand side, LHS is 1 minus 1 by x minus vt. RHS is 1 over b squared minus b squared by b x minus vt. Therefore RHS. Hence proof. Do you want me to go with same with equation this problem 21 as well?
For what, sorry?
So I solved this one. It's similar, and if you want, I can go It's a straightforward differentiation. But I thought some of you are not from mathematics, so like maths or physics, so you might find this helpful
Yeah, might
to
as
be
well.
solved here. Okay, I'll solve it. So the equation is given as, just have to prove that this satisfies wave equation, so we'll substitute it in the formula. So E is the exponential factor. Yeah. So dy by dx or phi dash can be written as E bx minus vt into b d2y by dx square can be written as E bx minus vt into b square. Okay. Y double dash dy by dt is written as E bx minus vt. Okay, tell me what should be d2y by dt square. Can you?
Um,
It's straightforward. You can try.
what we have to do to d square y dt squared,
So you differentiate this equation again
right?
to get d2y or y double dot y differentiated two times with respect to t. Okay, so it will be. Am I correct?
Yeah.
And there is always a b. Okay, b is outside the bracket. So no mistake. Substituting in the wave equation. Okay, cool. LHS is b square e bx minus t RHS. That's okay.
Yeah.
Therefore, LHS, it's proved. I hope that was straightforward. Let's go on to question number 23, or fifth question for today, and that is a sinusoidal sound wave moves through a medium and is described by the displacement wave. So whenever there is a sound wave, there is always a displacement wave. That's how it travels, right? Compression and rarefaction.
Right.
You guys read, Prof explained to you. So what is the amplitude? Okay, you have to tell me here.
2 micrometers.
2 micrometers or two? Yeah, it's micrometers. Yeah, perfect. Two microns. Okay. What is the wavelength?
0.4 meters.
That is 2 2 pi by lambda,
Yeah,
right?
is equal to 15.7.
Yes, so therefore lambda is 2 pi by k. This type of question comes in your exam? Or
Oh, I don't know.
this one?
We have a mock
Okay,
exam actually today and tomorrow, so I will
okay, okay.
see.
So speed, how will you find speed?
Um, I did 858 divided by 2 pi over zero point 0.4. But you can also do k divided by m, I think. Or,
Yes, directly,
yeah, that.
right?
Yeah.
Okay, let's move on to the last question. Okay, I think I finished today very fast. I'm not explaining at all.
I found some questions that I wasn't able to get actually, but I don't know if I just should send you an email after or if we can
What
try to
type of,
do them.
it's in the book?
Yeah, it's in the book.
Okay, uh, okay, let me solve this one first, then we'll talk about it. I'll stop the recording and then we can talk,
Okay.
right? Okay, a sound wave propagates in air at 27 degrees Celsius. So we'll so given answer given is 27 degrees Celsius, T and frequency 4 kilohertz. It passes through a region where temperature gradually changes and then moves through it air at 0 degrees Celsius. So let's say the wave was traveling into an region, and let me draw it properly. This was the wave, and okay, not a very good looking wave though. I'm not very good at drawing, so let's say this is 27 degrees Celsius and that is 0 degrees centigrade. Okay. Give a numerical answer to the following questions to the extent possible and state your reasoning about what happens to the wave physically. That's a good question. So, what happens to the speed of wave? Any guesses?
Um, it's slower
And you have to give the physical reasoning to that. Yes, you're right. It decreases.
because the temperature dropped.
So, what happens physically?
Um, well, I see it as like there's less energy because it's colder, so then the
Okay.
speed decreases. We also like when we were talking in class about temperature and its effect on speed, we just stated that it decreases.
That's it. Okay. So, colder air is more dense, right?
Right.
You can say if it's more dense, that's why the speed of wave decreases. You can say that. Second, you can say physically, in terms physically, I'm talking about, okay?
Hmm.
You're right. The speed of wave decreases, and how you can find it mathematically is using the formula. Yeah, you saw this in your class.
Yeah.
Temperature of the medium, right? So you can put 27 here, and you can put 0 here, right? Okay. So it's more dense. That's why the speed of wave decreases. Okay. Let's say you are going from dense material, then your speed or wave attenuates, right? It decreases. That's why speed decreases. Or you can say if the temperature is colder, then your particle in the air have lower energy, right? They
Right.
are at standstill. That means that compression and rarefaction that is needed for sound, right, in a medium, that needs vibration, and they have less energy. That means you can say the velocity decreases. It's a big reasoning, but you can say anyway. Or you can simply say it's more dense.
Okay.
Okay. What happens to its frequency? What do you think happens to its frequency?
It'll increase,
No.
decrease.
No.
It'll stay the same.
Yes.
Uh,
And why?
because the frequency is only dependent on the wavelength and
Okay, frequency omega v into k, right? Let's see mathematically first. Okay. Your k is okay. That's the answer to part third. But yeah, k is 2 pi by lambda, right?
right.
So if your speed decreases, your wavelength will change, right? Wave travels in the direction, right? So your wavelength will change, or you can say the crest here as I drawn. That's the part to part three. Okay, answer to part three. The what happens to its wavelength as because the velocity is low. Now the crests are more crowded, or they are together in compared to that. Okay,
Okay.
but the oscillation per unit time, that is your frequency, right? They remain unchanged.
Okay.
Okay, so because your lambda changes, so lambda v by omega. Okay, okay.
Okay.
So your velocity changes, so you can do v nu. Omega remains unchanged. So lambda changes by the same factor as your velocity. That's for your part third, and omega remains unchanged. Lambda 2 pi nu omega. Lambda decreases by same factor as velocity. If you think physically, it makes sense.
Right.
Okay, so you can always tackle the problem if you think physically in the question. You'll get the good hunch or better hunch. That's what I expect. If the answer is this, then I'm right. Okay, so I'll the today's session. Today's session that was quick as well. Today's session was about traveling motion of waves or wave motion, and we covered more or less your chapter 16 of the book. Okay, officially I'll turn off the recording. Then you guys can. It's only two of you, so you guys can chat or all of us can chat.
Yeah. So I just